Welcome to this demo session on GenAI. So the entire demo will, or the agenda of the session is first we will understand GenAI. On a high level, we'll see how these AI models are trained, such as ChatGPT. So how it is trained, we will see that. And after that, we will see a demo stating that how or how we can use these GenAI capabilities to solve some exciting use cases. So when I say GenAI, what exactly it means? It means generative AI, generative artificial intelligence. So what it says, it means it is generating something, yeah. Artificial intelligence which can generate something. That is a GenAI. And what are the different GenAI models you have seen? Anyone who have used any of the GenAI models so far? Anyone? You would have used this ChatGPT. You would have used Rock. You would have used Gemini. You would have used Sora. You would have used Vio. You would have used DeepSeek, Kimi, and many more. The list goes on. And here I would like to include the DALI also. So these are the different models, GenAI models, and these are called LLMs, large language models. Okay. So we have just listed the different models you have in the market, which you consume directly or indirectly. If you talk about the Copilot, I think some of us use Copilot. If we are from the development side, we use Copilot or Lovable or Bolt, any of these things. For this Copilot, the underlying LLM model is nothing but the Chat GPT model. For Lovable, it's a mix of different models. For Bolt, which gives you the code generation thing, it is a mix of different models. However, the main question is how these models are trained and what exactly the training means here. Because all these models looks like doing some magic, but it's not doing the magic. It's purely maths playing behind the screen. To understand, let me give you a small example. Let me plot a graph, and suppose this is how your data spread is. Each dot you see here is your data, and this is how your data looks like. You plotted on a graph, and you have seen this is my data. Now, can I make a model, or can I use a function which represents or which closely or very approximately covering these all data points? So the kind of graph which covers looks something like this. And whenever a data point comes in, the x data point comes in, the y can be predicted, and if the data point will be predicted on the line, yeah, there will be some error. In ground truth, in reality, your data point might have this value, but when you predict it, your value might be this. So that's why we say it's a prediction. Prediction cannot be 100% correct, right? It's a close estimate of the actual thing. That is what a prediction is. And this is, I'm telling, only one of the simplest way to understanding of how these any machine learning models or AI models works. However, when we go to the LLM models, the complexity increases a lot. Here we have used only single function to represent this data we have in the distribution. But when we talk about the LLM model, you use n number of such small functions, okay, to make it a big one. So you can say you add a small plus small plus small. That makes you the whole model. So the complexity here increases a lot, increases by multifold when compared to the normal this kind of a data. And the multitude of complexity you can understand if I tell you, if you would like to train an LLM model or create an LLM model, you need to use a GPU. The cheapest GPU, I think you might be aware of, starting from 15K, no use. For such kind of models, at least for a retail people, such as like you and me, 4090 is a starting point, the GPU. And this cost at least 2 lakhs, approximately 2 lakhs. Then 5090, that is approximately 3 lakhs. And this just can handle certain level of complexity only. However, if the complexity increases even more, then A100, which cost itself 15 lakhs, and that is approximately equal to, I think, 10K US dollars, approximately. Even this is not enough. Just to let you know, the Llama model, which is created by Facebook, Llama model is created by the Facebook. They used 16,000 H100 GPUs to do the training. And this one H100 cost you 30K to 40K dollars. So now you understand how complex work it has to do, because of which you have to use this server grade level GPUs to get something like Llama or GPT. I hope we understood the complexity of such LLM models. Now we understood the complexity of such LLM models. Let us understand how LLM model is trained. Okay, the first step is you create your foundation model. We will see what exactly happens in the foundation model. So in this foundation model, you collect all the data around the world. Whatever data is at your disposal, you collect all the data and you make your model. And the model you create here is called foundation model, because this is acting as the first step to your building your LLM model. However, this model has all the knowledge. This model has all the knowledge. However, you cannot use this thing as is for chatting purpose. The way we have used the chat GPT or Gawk, where I pass a message, I get a response, etc. You cannot do that. Now, to build that capability, we go to the second step, which is called SFT, supervised fine tuning. In supervised fine tuning, we build a data set of conversations. A person like you and me, who has expertise in that, he creates the user question and the response. If I'm saying, how are you? For that thing, he's designing the response. See, I am, say, GPT. So this is what person acts as the user, and the person acts as the AI also, or let me say our LLM model, to build these responses, the user questions responses. Now, after this data is done, your model is trained on this data. Now, why we are doing that? Because by training on this data, your model starts understanding, if I get this kind of an answer, how should I reply? Okay, it's learning, it's not memorizing the response, it's learning. And that's what happens in SFT, supervised fine tuning. So at this stage, you can start doing, after the end of this stage, you can start doing that chatting. However, even this is not enough. Why not enough? Now, I started building my foundation model. Suppose my foundation model, I built the completion. The model is ready by, say, 30th of October. My foundation model is ready. Okay, my foundation model is ready. After that, I took nearly 1 month. One more month means by end of the November, I got my SFT trained. And supervised fine tuning is done. If you see here, there is a 1 month gap approximately. And before that also, when you're training your model, you would have collected your data, say, suppose on 30th of September. Since 30th of September, for 1 month, you have trained your model, because training such models will take good amount of time, months, days also. So now when you are training this thing, the data or the data, the new data or the new information which flown onto the on the internet, you did not cover that. Yes or no, you missed that data. Here, 1 month here, 1 month here. So 2 months data, you missed it. Okay. Now there is a problem here. Now for that thing, use RLHF. Reinforcement learning human feedback through human feedback through human feedback. So we try to address this challenge, not 100%, but we try to address how. We say, I said, tell me who won in election. Okay, we are assuming some election, and this election happened during the period when the model is getting trained. So it will definitely reply something. Why it will reply something? So your LLM model, you can think as a person. You put any question to him, whether he knows or does not know, he will give you some answer. Okay. If it does not know the answer, he will cook the answer and give it to you. Same thing happens with the LLM model. It does not matter whether it knows or not, does not know, but it will give you the response. And that's what it is designed for. However, in this particular step, RLHF, reinforcement learning through human feedback, when you ask something which and the response which you got, it's not apt or it's not a correct way, the tone, etc., it's not good, then human gives a feedback. And based on the feedback, again, it refines the response. Now here, a person will act as a user and the LLM model AI will act as a AI. In the previous step, both the roles were played by the human, but in this case, the second role, the AI role, will be played by the AI. Okay, so on the other hand, this is how the LLM model or the specifically GPT model is trained. Yeah, just for illustration purpose. So now this is your user question and a response. The data structure might be in the JSON format. That's altogether different story, but I'm just giving you how the data looks like. Here is a how are you? And the response is I am fine. How are you? Same question. Okay, same question might have different answers, right? Great. What about you? Okay, such in that sense, you build a big corpus of this information. And then you train this thing you train this thing, or your foundation model is trained on this thing. So it understand, if I get this thing, I have to respond this thing, or not this thing, exactly this thing, but as a different variations of the same question, there is different responses for the same question. It learned from it, and it says now it might, if you go to the final one, if you say how are you, it might say great, I am fine. It might reply this. It might. Okay. Why it's replying so? Because it has learned it. Okay. Behind the scenes, how it works. Okay. That is not scheduled for today. When we go deeper into this training part, we will see a small demo on that during the sessions, the other sessions. But I will give you the heads up that we cannot do if I plan to do the training, that would be a Herculean task for us. So we will be seeing a small data set. Okay, we will try to simulate that particular scenario. We are not gonna prepare the entire new foundation model or LLM model. That's not possible with the resources we have at our disposal. Okay.
Okay.
Basically, if I tell you for this particular course, we don't have any prerequisite because we start with the Python. If you are good with the Python, that's totally fine. If you don't know the Python even totally, that is fine. After that, we build some of the NLP concepts. Okay, which because NLP is natural language processing, where you work with the text data, and more or less these foundation models or this LLM works on the text data. So we will understand the basic concepts of NLP. Then we start with GenAI. We will understand the transformers, okay, which is a heart of these LLM models. A transformer has two parts to it, and those things we will learn it. Okay, so this gives you the foundation understanding of GenAI and the transformers. Okay, now your foundation is laid. Combine these four. Now we go one step deeper. Where we try to understand different challenges with these GenAI models. Okay, we will try to understand the RAG. Okay, now we see this how RAG helps us with this thing. We will do a couple of projects. We try to do a bit of fine tuning using LoRa. Okay, I think if you did not hear these terms, that then this would be some very technical terms. However, this we can use the fine tuning, etc. So this is how the flow goes. So you don't need to have any prerequisite. Only one thing you need to have. The first thing is consistency, because I've seen the people join the session with very good enthusiasm, but halfway through, the entire enthusiasm goes off, and that's still fine. It happens. But after again pulling ourselves on the same pace is a bit of challenge. If you could commit me the consistency, I could commit you the course with the zero prerequisite. So only requisite I have the consistency, or this course has that, nothing else. Now, here I told you in RLHF, you do these things, okay? You do a do a prompt, AI gives you the answer, and you label it correct or not. And this type of things you would have seen on your chat GPT or Grok. Sometimes if you ask a question to chat GPT or Grok, it gives you response one and response two, right? Did you observe these things? Response one and response two. And now it asks you to choose which response you prefer a lot or you liked a lot. If you choose one response, in the future also, if you ask a similar kind of questions, it gives you the response in that particular format or so. But did you see this particular situation where for a single question you got two ways of answering the same question? But it does. So this is also, you can say, kind of a RLHF, reinforcement learning through human feedback. However, after this thing, you say, Vivek, in RLHF, we are trying to somehow saying the LLM model that if you don't know, don't give me shit. Just be very straightforward if you don't know. So that's how you're building here information. The next question you people should have stating that, Vivek, what about I have a new information available on the internet, or I have my office related documents on which I would like to make this LLM model. So I would like to create a chatbot on my office documents, and this LLM model was never trained on my office documents. If I ask a question, it will puke something or the other, but which is not correct. And to save us in such situation, you have a RAG, retrieval augmented generation. And with that, you have the fine tuning also, both. However, in some cases, you only go with the RAG, some cases fine tuning your LLM model, or in some cases, you think of using hybrid. Okay, correct. We will just see the RAG architecture on a high level currently. How it looks, if you see any LLM model, okay, how the communication happens or how the information is transferred, you do have a user, you have your prompt. Here is your LLM model. And as soon as the prompt is hit, it gives you the response. Okay. Now this prompt, which you're sending to LLM model, the prompt related information your LLM model might not have, but it will give you the response. However, when the RAG comes into the picture, you have a couple of additional components. This is your vector DB. Okay, now here you have your user. And before sending your prompt to the LLM model, it sends that prompt to your vector DB. In vector DB, whatever prompt you're sending here, that is compared with all the information this vector DB stores. And if it gets matches, here the matches is nothing but the other information which is similar to the prompt, it sends it back. And the sending back is nothing but your context. And now you add your prompt and context, both, you send it to your LLM model. Now the LLM model has the context that what is the information. Okay, similar thing you have, it is a prompt. Now it uses its understanding. It understands the context, it understands your prompt, and it sends you the reply. It sends you the reply which is with respective to the context which you're sharing with your LLM model. So this is nothing but your RAG architecture. Okay, now before I start this thing, let me show you something. Now this is an image, right? By seeing the image, what are the different things you observe? What do you observe about this particular image? You can say there are students who are sitting and chilling with their friends. Okay, and about the background, it is very green background, etc. Right? So if I ask you to explain this, this is what you explain, right? Yes or no? What if you can create a model which does it for you? You can clearly create it. Previously, before this LLM models, okay, you have to explicitly train the model, okay, and get it done. But now, since 2022, when the first GPT was introduced, and now you don't have to put a lot of time on training or those things. You can simply use the existing intelligence of the LLM model, add your side of a flavor or additional knowledge you have to add it, and boom, your entire new application is ready or a problem is solved. Okay. So this particular demo, we will be doing the same thing where we will be passing a particular image and it analyzes and describes that particular image. So now this is only about the image I'm talking. I can have the live camera. Okay, I can provide create a solution which captures the live person's photo and it try to analyze the surroundings. Now you might ask, what would be the use of that thing? If I'm capturing the live picture of a person and I'm trying to analyze the surroundings. Think of a proctoring. You would have given some proctoring exams, right? Proctored exams. Did you? It every now and then captures the images, and then if you go out to the screen and those things, it gives you some warnings. That's what the proctoring happens. However, you can add AI functionality. It try to read the uh, you know read the surroundings of the user, and you can specifically more train it, okay, or fine tune it to understand if some other person exists in that room or not. Okay, because if suppose I'm sitting in a room, I have a uh, mirror at my back, and some person is truly standing besides my monitor, his reflection will fall into the mirror, right? And if I develop this kind of solution, it will analyze the entire background and it will definitely capture that information also. Can we use this particular small demo approach to build such kind of thing? We can, right? Okay. With that, let us try to create this thing. So choose a file, knowledge, and I'm trying to do analyze. You try to access open strategy, but this is no longer supported. Here's some error. with the versioning. Okay, here I got a error with the versioning. However, in a nutshell, I think you understood what exactly I would like to show it to you. So now with and to develop this thing, let me show you how many lines of a code I required. Yeah, how many lines of code? Hardly 34, 33. And with that, in that also starting couple of lines is to import the required modules or a Python libraries. And main magic happens at this area, at this function, and specifically the magic happens here, where you're set writing your prompt and passing it to your LLM model. After that, you are here collecting the response, and you're just showing the response. So this is the main magic. Why I'm saying this is the main magic, though here I'm not calling calling any LLM APIs. I'm not calling it. However, this is a prompt, and I think we have seen an example where how important the prompt is, and how structured, how well you have to make your prompt so you get the apt answer. So this is the magic part, I can say. Now you get a response, you can display however you would like to have a response. Now here I got a error stating that chat completion.create is something not supported with the current version of the OpenAI module I'm using. That is the error I got it here. Okay, but you can see nothing more. And this is the backend code I'm talking about. Yes, you will have your front end also, but I'm purely talking about the backend where the main magic, main processing, heavy lifting happens. A less number of code, and with this less number lines of code, I think we get a confidence that we can go think out of the box, create something which does not require us to bang our head, write hundreds and thousands lines of code. Yes or no? Based on the complexity, it might increase, but for our use case, a small demo, this is what I have written.